All right, chapter 12 starts off with lines that intersect circles. And your first couple of definitions are the interior and exterior of a circle. I sure hope there's no confusion on those two. This would be the interior of a circle. Yeah, just hopefully if you, And the part that's not inside the circle, that's called the exterior of the circle. All right, and then just a bunch of definitions, okay? Starting off with a chord. Which is a segment whose endpoints lie on a circle. So there it is. AB is a chord. A secant is a line that intersects the circle, a line that intersects a circle in two places. So there you go, secant. See the difference? The secant's a line, isn't it? The chord is a segment. And a tangent is a line that intersects a circle at exactly one point. Ba-bam. Tangent. A tangent is a line that intersects a circle at exactly one point. So this tangent intersects this circle right here. We'll call it point C, and it has a name. It's called point of tangency. That's where the circle intersects the tangent, or where the tangent intersects the circle. Either way. Point of tangency. The line itself is called a tangent. Where the circle and the line intersect, that one point is called your point of tangency. Top of 793, congruent circles. Congruent circles, two circles are congruent. If and only if they have congruent radii. Radii. Concentric circles. Are coplanar. And have the same center. So that's just a circle inside of a circle. Or out. Oh. This is a tough one here. Just pretend that this circle is just a little bit bigger than the first one. There. Those two are concentric. Two circles that have the same center. And tangent circles. Two coplanar circles. Two coplanar circles that intersect at exactly one point. Are tangent circles. They just kind of rub up against each other. You know what I'm saying? And then they just kind of, oh man. Not that. Are those tangent circles?
No.
No. What about those? No, because they intersect at more than one point. What about those? Yes, very good.
So like you could draw like a figure 8. And
Correct. Figure 8, snowman. As long as you're figure 8, they're circles. So what would that red point P right there be called? Point of tangency. Very good. Point of tangency. All right, example 2 there talks about find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. So what you've got there in example 2 is two circles. All right, you got a bigger one, and it's got a smaller one inside of it. And this is going to be a bad circle, probably. There. You got something that looks like that. You've got this point right here, and then you've got a vertical line. And it's all over a coordinate plane. And they ask you to find the length of each radius. Well, if you look at the big circle, Point A is its center, isn't it?
Mhm.
It's got a point A right here. Well, how many units is it from A to the edge of the circle? Just
Four.
count them. Yeah, it goes from -1 to -5, right? If going to the left. So the radius of the large circle, find the length of each radius. The radius of circle A is 5. The radius of circle B, this is here, this is here, right? And that goes from 1 to 4, doesn't it? 1, 2, or it goes from 1 to 3.
Yeah, for two.
The radius of A is 4, yeah, because it goes from -1 to -5. Agreed? From -1 to -5, so that's 4 units. And what's the radius of circle B?
Two.
2 units, okay? Identify the point of tangency. The point of tangency is at, what are the coordinates of that point? What's the x value at that point of tangency right there? Isn't it 3? And 0 on the y. Okay? Write the equation of the line at this point. So the equation of a vertical line, all right, vertical line at 3, 0 would be x equals 3, wouldn't it? All vertical lines are x equals lines. All horizontal lines are y equals lines. Okay? What would be the check it out on the bottom of 793? What's the point of tangency there? Of the two circles? 2, -1, right? What is the equation for that horizontal line?
Y equals -1.
Y equals -1. Very good. Y equals -1. All right, moving along. Top of page 794. A common tangent is a line that is tangent to two circles. A common tangent is a line tangent to two circles. And they give you 2 examples. So look at them both, write them both down if you want. There's 2 ways that they can be tangent to 2 circles. So you've got this case. Where the lines are tangent outside the circles. See it? No, I'm going to curve my line there.
So aren't both of them?
L is tangent to both circles. All right? In this case, you got circle A on the left, circle B on the right. Line L is tangent to both circles. Agreed? And then line M. See if I can get it tangent there. Ah, man. Yeah, you need a straight edge would help, wouldn't it? Just gotta kind of hit that right there. Hit it. There. It's tangent right there and there. M is tangent to both circles as well. All right? The other example is when you got circles here and here, and then the tangents run in between them. See the difference? I'm struggling with my tangents. I apologize. Just pretend these lines are straight and that they're touching. Okay? So that line, line P is tangent to circle A and circle B. And so is this line right here. There. Call it line R. Thanks. As long as it's only touching each circle at one point. A lot of definitions, right? A lot of definitions so far. So look down at the theorems on page 794. It says if a line is tangent to a circle. Then it is perpendicular to the radius drawn to the point of tangency. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So if you get a circle on your paper, and that circle has a tangent, if a line is tangent to a circle, so if I take a line and I make it tangent to a circle, that means it's going to intersect the circle at exactly one point. Right here, P, point of tangency. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So if the radius goes from the center of the circle to the edge of the circle, but we draw the radius from the center to the point of tangency, what angle does that form? Forms a 90-degree angle. Very good. Perpendicular to the radius drawn to the point of tangency. Okay? Red line is the radius. Black line is the line, it's tangent to the circle. If the radius is drawn to the line of to the point of tangency, then it's perpendicular to the tangent. Got it? Then look at the second part of that theorem. If a line is perpendicular to the radius of a circle at a point on the circle, then the line is tangent to the circle. So that's the second part of the theorem. Probably ought to get that in your notes too. If a line is perpendicular to the radius of a circle. So if a line is, here's the symbol for perpendicular, it's the upside down T. If a line is perpendicular to a radius of a circle, at a point on the circle, then the line is tangent to the circle. Everybody all right so far? A lot of definitions. Page 795 down on the bottom. If two segments are tangent to a circle, if two segments are tangent to a circle, from the same external point, then the segments are congruent. So here would be your application. You got a circle. You've got a segment that's tangent and another segment that's tangent. And they come from the same external point. Both of the segments start at point A, but they're tangent to the circle at two other points, B and C. The theorem says that AB will be congruent to AC. So if you were given something like AB is 5y minus 28, and A to C is 3y, and you're asked to solve for y, you would set the two expressions equal to each other. You would make 5y minus 28 equal to 3y. You can subtract 5y from each side, and negative 28 would equal negative 2y. Divide both sides by negative 2. And 14 would equal y. Agreed? So they could ask you to solve for y, or what else could they ask you? Yeah, exactly. So find AC. All right, so A to C is going to be equal to 3 times 14, right? So it's 3 times 14, and what is that? A to C is going to be equal to 42. Simple enough? Your assignment for today. Page 797. Problems 4 through 10. And check headline for homework.